Topic 25, Motor Effect, Part 3. We're looking at electric motor. In an electric motor, we are applying the motor effect that you have studied on a coil like this to make it rotate. So first of all, let's look at the external circuit here, including this brush contact and that brush contact. All that is fixed. And this two halves of a ring is called split ring commutator. That's attached to this coil, which is made to rotate. Now if you apply Fleming's left hand rule to each of these two sides of the coil, you'll find that this side gets pushed up. The magnetic force on this side is up. The magnetic force on this side is down. So this coil rotates that way. Electric current flowing around the coil of the electric motor produces oppositely directed forces on each side of the coil, this side and this side. On this side, the force is up, on that side, it's down. And it says here, these forces cause the coil to rotate. It rotates that way, clockwise. Every half turn or half revolution, the split ring commutator, this one here, causes the current in the coil to reverse. Otherwise, the coil will just stop in the vertical position. Let's take a closer look at the electric motor. First of all, current comes out of the battery, flowing along here through the contact brush, through this half of the split ring commutator, into the wire, and into the coil, all the way, then out this way, through this half of the split ring commutator, through this contact brush, through the wire, all the way back to the battery. Now, the magnetic field lines are going from north to south, so it's that way. And look at this side of the coil. The current is arrow page. And so if you apply Fleming's left hand rule, you find that the thumb points up this way. The magnetic force on this side of the coil is up. So this side will get rotated up, and the other side will get rotated down, because the current in this half is going the opposite way. So the coil rotates that way. Now the coil has turned through about 45 degrees, and the current is still flowing through the coil, and so these two oppositely directed magnetic forces still there, turning the coil clockwise. Here the coil is in the vertical position, and it says here brushes lose contact with the split ring commutator. You can see that these two brushes are not in contact with the commutator. Current no longer flows through the motor coil. There's no current flowing. The coil will continue to rotate clockwise due to its momentum. The coil has now rotated past the vertical position, and brushes regain contact with the split ring commutator. You can see that. Current flows through the motor coil once again, but in the opposite direction. You can see that. Forces exert a clockwise turning effect on the coil again, so the coil keeps turning clockwise. The coil has turned through half a turn or half a revolution, or 180 degrees, and brushes regain contact with the split ring commutator. Current flows through the motor coil, but in the opposite direction. Forces exert a clockwise turning effect on the coil, so the coil just keeps turning clockwise. The motor coil has turned through another 45 degrees, but the contacts are still there between the contact brushes and the split ring commutator. Therefore the current is still flowing, and the magnetic force is still there. The coil keeps turning. The motor coil has now turned through 3/4 of a revolution, and once again is in a vertical position. Therefore there's no contact between the contact brushes and the split ring commutator. So current no longer flows through the motor coil, but the coil will continue to rotate clockwise due to its momentum. The motor coil has turned through a further 45 degrees, and now the brushes regain contact with the split ring commutator. Current flows through the motor coil, but in the original direction, back to original direction. Forces exert a clockwise turning effect on the coil, so the coil just keeps turning clockwise. The motor coil has turned through a complete revolution back to the starting position, and the same thing starts all over again. This is the construction of a model electric motor.